Well, this video is to finish up section 3.3, and then we'll have 2 videos to go over section 3.4, and then that'll be it. So let's go ahead and take a look at some of these problems. So we left off, I think it was problem 11. So let's, and most of those really just had the variable on one side of the equation and not the other. So let's jump in and take a look at some that have variables on both sides. So for instance, 14 I think is a good problem. So here we get 2 to the x plus 1 power equals 3 to the x minus 2 power. And remember, to solve these, we're going to be using this property of logarithms that says if you take a log of something that's being raised to a power, that power can come down in front as a coefficient. And we talked about why that's true, and that's all in the textbook again if you want to take a look at it. And we also talk about it, or I also talk about it in that previous video, the one right before this one. Okay, so let's apply that to solve this equation. Let's see, I'll use log base 10 here. So we'll take a logarithm on both sides of the equation. And then those exponents can come down in front as coefficients. And this will be x minus 2 log 3. Okay, so again, at this point we have a choice. We can hold on to these logarithms and solve them and get an answer that's in terms of those logarithms, or we can approximate them right here and then just solve numerically. So I'll do that first, and then we'll go back and take a look at the exact value answer. Alright, so let's see here. So first we want a good approximation for the log base 10 of 2, and I think 0.30103 is a good approximation there. And let's see, log base 10 of 3, 0.47712. 47712. And this is times x minus 2. Okay, so this will be 0.30103x plus 0.30103, and over here 0.47712x minus, let's see, let's go ahead and just multiply here. And so that'll be 95424, 0.95424. Okay, great. So now let's get our x's together. I'll subtract this over here. So this will stay where it is. And then over here, 47712 minus 0.30103, 17609. 95424. So then we now want to add this over to the other side. Those cancel out. This stays the same. And then over here, we're adding, let's see, it'll be 7255, 1.25527. 25527. Great. And then we'll divide on both sides by 0.17609. Those cancel out. And let's see here. Divided by 0.17609. And this comes out to be about 7.129. If we were to round this to 3 decimal places, it would be 7.129. If we were concerned about accuracy, I would round this to the 7.1286. Alright, I think that'll give us a much more accurate answer rather than calling this 129. But in any event, we can go ahead and we can check this answer, right? If we do 2 to the 8.1286 power, 8.1286 279.867, right? Because the 2 is being raised to the x plus 1 power, and then the 3 is being raised to the x minus 2 power, so this will be 3 to the 5.1286. And that'll be 279.875 or so. So these are pretty close. They're off in the hundredths place. And as always, if you want better, if you want a better answer, if you want these to be closer, then you just need more digits after that in the answer. All right, let's back up and take a look at what would happen to this if we held on to these logarithms and just solved it like that. So this would be x log 2 plus log 2 equals x log 3 minus 2 log 3. So let's see here. We take x log 2 plus log of 2 equals x log 3 minus 2 log 3. So in a similar way that we did in the previous method, I'm going to subtract this x log 2 on both sides, and then also I'll add the 2 log 3 to both sides. So those cancel out. Over here we get x log 3 minus x log 2, and over here log 2 plus 2 log 3. And remember, the trick here is factor out the x, and then you can divide on both sides by the log of 3 minus the log of 2. And so there's our answer right there. Log 2 plus 2 log 3 divided by log 3 minus log 2. And if we calculate that, we should get that same 7.1286 number. Let's see here. So log 2 plus 2 log 3. And then we want to divide that by log 3 minus log 2. And there's our 7.1286 approximately. And there's what it looks like, the approximation on the calculator. So there I just calculated the numerator separately and then divided that by the denominator. And notice that I've got those extra parentheses around the denominator. Otherwise, we wouldn't get the correct answer. Okay, well that's problem 14. Let's see here. Let's take a look at 16. So, problem 16, we start out with 7 to the x minus 3 equals 3 to the x plus 1. Okay, so let's see. I used log base 10 on that previous problem. So let's use natural log ln on this problem. So we'll take a logarithm on both sides, and then we'll get x minus 3 times ln 7 equals x plus 1 times ln 3. Okay, and then I'll do the same thing that I did in that previous problem. I'll approximate both of these values and then solve the problem numerically first. So let's see here. X minus 3, ln 7, 1.9459. And then on the other side, x plus 1, ln 3, 1.0986. Okay. So, let's go ahead and distribute here. 1.9459x minus 3 times 1.9459, 8377. Okay, and then over here, 1.0986x plus 1.0986. All right, let's see. I'll subtract this over to here, 1.0986x. And let's see here, what are we going to get there? 3778. Let's see. No, 4. Okay, so 0.84, yeah, 8473. That's why I don't do those in my head. All right, 5.8377. We'll add this to both sides. So over on this side, 1.0986, 5.8377, 6.93363. Okay, looks good. Now we'll divide on both sides by 0.8473. So 6.9363 divided by 0.8473, 8.186. Okay, so let's see. Let's check our answer. If we do 7 to the 5.186, because this is x minus 3. So 7 to the 5.186. 24,136.73, and then we do 3 to the 9.186 because this is x plus 1 here. So 3 to the 9.186, 24,145. So we're off in the tens place here. We're off by about 9 here. And again, if we want these to be closer, we're going to need more digits on the end there. Okay, but they're close enough to give us confidence that this is a good approximate value for the answer. Okay, so now we'll go back and we'll solve this with the exact value. So let's see. If we distribute inside here, this would be x ln 7 minus 3 ln 7. Distribute in here, x ln 3 plus ln 3. So now we'll add the 3 ln 7 to both sides. And then we'll subtract the x ln 3 on both sides. So we get x ln 7 minus x ln 3 equals ln 3 plus 3 ln 7. All right, so let's give us some more room here to work with. And then we need to factor that x out of these two quantities, two expressions. And then divide on both sides by ln 7 minus ln 3. And so there is our exact answer. So let's see. Ln 3 minus 3, plus ln 3 plus 3 ln 7. And then we're going to divide that by ln 7 minus ln 3. And so we get 8.186. Okay, and there's the approximations on the calculator there. Okay, and again, I calculated that numerator separately so I didn't have to mess around with the parentheses in that, because making these calculations really is dependent on doing that correctly. All right, that's number 16. We'll look at a couple more here. All right. 18. Let's see, we start out 9 to the 1 minus x equals 12 to the x plus 1. All right, well, let's see. I think I'll use the log base 10 on this one. Say log 9, take the logarithm on both sides, and then the exponents come down in front. 1 minus x log 9 equals x plus 1 log 12. Okay, well, let's get some good approximations here. Log of 9.9542. And on the other side, log of 12, 1.0792. Okay, so we'll distribute inside here. 0.9542 minus 0.9542x equals 1.0792x plus 1.0792. Okay, let's see here. So, let's add this to the other side, 9542x. Let's see, 43302x. 9542. All right, let's see here. So now we want to subtract 1.0792 on both sides. And notice we're going to get a negative number over here, and that's okay. If you're ever not sure whether or not your answer is correct, plug it back in and see whether or not those things turn out to be approximately equal to each other. Okay, so over here we're going to get negative 0.125. Negative 0.125, and then divide on both sides by 2.0334. And we get x should be approximately negative 0.061. Okay, well, let's see whether or not this will check. 9 to the 1 minus negative 0.061. So that's going to be 9 to the 1.061. 10.29. Okay. And then let's see here. 12 to the negative 0.061 plus 1. And that's going to be about 0.939. So 12 to the 0.939, 10.31. Okay, so not bad. They're close enough for our purposes. If we wanted a better approximation, we could find the exact value, which I'll do in a minute. And let's see, I'll leave those approximations up there to see how close our answer is to the one that we get from the exact value. So let's see how this works. Let's see. So we're going to distribute first. So we get log 9 minus x log 9. Distribute here. X log 12 plus log 12. And notice as I go through these two different methods, notice I'm doing the same thing in both methods, right? And in that other method a minute ago, I added this over here and subtracted this over here. I'm going to do the same thing, it's just going to look a little bit different. All right, so we're going to add x log 9 to both sides. Those will cancel out. And then subtract log 12 on both sides. And this is where we got that negative number. in doing the other method. Here it's kind of hidden that it's going to end up as a negative number, but when we approximate it, it will. So we'll have log of 9 minus log of 12, and that'll be equal to x log 12 plus x log 9. Right? And then we want to factor the x out here. And then we can divide on both sides by log 12 plus log 9. So those cancel out. Let's look at what that approximation looks like on the calculator. Let's see here. Log 9 minus log 12. And then we want to divide that by parentheses log 12 plus log 9. Still get negative 0.061. Okay, let's see. And there's the approximation there. Okay. Let's see, let's get the camera to focus. There we go. All right. All right, let's look at one more problem here. I think problem 22 is a good problem here. Okay, problem 22. 2 to the 2x minus 3 equals 5 to the minus x minus 1. All right. So, let's see. I'll use the natural log on this one. Take a logarithm on both sides. Then we'll have 2x minus 3 times ln 2 equals negative x minus 1 times ln 5. And now let's get good approximations for those. Let's see here. ln 2, 69315 times 2x minus 3. And then the ln 5, 1.60944. 60944 times negative x minus 1. Well, this is easy to distribute. So this will be negative 1.60944x minus 1.60944. Let's see, over here we got to do 0.69315 times 2, 1.3863. And then 0.69315 times 3, 2.07945. Okay, let's see. Let's add this to both sides. So those will cancel out. And let's see. 1.3863 plus 1.60944. So 2.99574x. And then we still got this 2.07945 and minus 1.60944. So now we want to add this over to the other side. 2.07945. So, negative 1.60944 plus 2.07945, 0.47001, and then we want to divide on both sides by 2.99574. Let's see here. So divided by 2.99574, about 0.157 is a good approximation. So let's see here. Let's do 2 and go 2 times 0.157 minus 3. And I'll just leave it at that. I'm not going to calculate what that is. And let's see. About 1.1553937. And then we'll do 5 to the minus 0.157 minus 1. 5 to the minus 0.157 minus 1, 0.155343. So not bad. We're good up to the 10,000ths place there. We start to lose our accuracy in the 100,000ths place. But in general, this is a pretty good approximation. Okay. So let's go back and see what happens if we save the approximating for the very end. Alright, so we distribute here and here, so we'll have x times 2ln2 minus 3ln2 equals negative x ln5 minus ln5. Okay, and again, I'm going to do the same thing we did with the approximated values. I'm going to add this x ln5 to both sides, and then I'll add this 3ln2 to both sides. So we'll get x times 2ln2 plus x ln5 equals 3ln2 minus ln5. And then we got to factor out the x here. All right. Then we're going to divide on both sides by 2ln2 plus ln5. Those cancel out. And there's our exact answer. But as I like to say, exactly what? I mean, what is this number? So that's why we want to get a good approximation for it. So 3ln2 minus ln5. And then we'll divide that by 2ln2, oops, almost forgot my parentheses. Parentheses, 2ln2 plus ln5. And we get approximately 0.157. It's 15689 if you want to go a couple decimal places past it. But again, pretty good approximation there. And there's what it looks like on the calculator. All right, I calculated the numerator first and then divided it by the denominator to get that 0.157 answer. Okay, so that'll do it for section 3.3. All right, and like I said at the beginning of the video, we'll come back and wrap this up with section 3.4. And I'll split that into 2 videos as well, and so we will see you then.